Hello. Today we're going to do some notes on page 233 of the binder. We're going to learn about this big important new word called polynomials. Maybe you've heard of that word before, maybe not. But this whole chapter is going to be about polynomials. And this section we're going to learn some definitions, including what is a polynomial. And then we're going to add and subtract polynomials together. So to start off, we have this word monomial, okay? Mono means one, all right? And so monomial is one term, okay? And that nomial part kind of means number term. So when you hear monomial, it's something that has one term, okay? Now there's an important part of this is that it also has non-negative integer powers, okay? Meaning any exponent has to be non-negative, so it could be 0, it could be 1, it could be 2, it could be 3, and it has to be integers, so there's going to be no fraction exponents either, which is nice. Okay, so you see a bunch of examples here. 13 is a monomial. 3x, negative 57, x squared, 4y squared, all of these, negative 2xy, 520x squared, y squared. As long as it's a single term, so there's no addition or subtraction, then it's a monomial. Okay? Now a binomial, if you think bicycle, two wheels, binomial has two terms. Okay? And they have to be unlike terms because you couldn't combine them into one. So the sum of two monomials. All right, so a couple of examples might be, 3x plus 7. Or another example would be 9x squared minus 1. Okay. Those are two examples of binomials. All right. Trinomials have three terms, tricycles, 3 wheels, trinomial, 3 terms. All right. So an example could be something like x squared minus 2x plus 18. That's a trinomial. All right. Notice the pluses and minuses, those separate the terms. All right. In monomials, there were no pluses or minuses separating two terms. So a polynomial has many terms, okay? And actually, all of these are polynomials: a monomial, a binomial, trinomial. They're all examples of polynomials, right? And a polynomial just could have any number of terms. So something like 4x to the third minus 8x plus 1, that is a polynomial. Okay, something else that's a polynomial is 14. Okay, one term could be a polynomial, or just 7x, or 3x minus 11. Okay. Those are all examples of polynomials. Something that's not a polynomial, okay, if I have a negative exponent, 6x to the negative third, that's not a polynomial. If I have a variable in a denominator, okay, 2 over x, that's not a polynomial. Or if I have a fractional exponent, like even if I did like 2x squared plus 3x to the 1/2, that is not a polynomial because of that x to the 1/2. All right, so we have those terms: monomial, binomial, trinomial, polynomial. We also have this word called degree. Okay, the degree is basically a measurement of how strong the polynomial is. Okay, and that's how strong, and I'll put that in quotes because it's not really a mathematical term there, how strong the polynomial is. Okay, and we measure the degree by the highest exponent. Okay, so that degree is the highest exponent. Okay. All right, so if we have the highest exponent is 0, that would be like 14, x to the 0, okay? Then we call that constant, right? There's no variable there, so it's constant. For something where the highest degree is 1, so that means the exponent is 1, 7x is a good example of that. We call that linear. Quadratic is if the highest degree is 2. Here's an example. Oops, you can't see that one. Hold on. I'm going to bring this back down. Here's an example of a quadratic because the degree is the highest exponent is 2. And then we can build up from there. Cubic is the highest exponent is 3. quartic, 4, quintic, 5. And then if it's bigger than 5, we usually just say the nth degree. So these 6 words here, constant, linear, quadratic, cubic, quartic, quintic, are words you need to know. Okay, and we'll practice that in a minute. All right, leading coefficient is the coefficient of the highest degree term, so just the number in front. Okay, so for 7x to the 5th minus 3x plus 1, we'd say the leading coefficient is 7. All right, and then finally, the last vocab word we need to know is standard form. Standard form means everything is combined, so all the like terms are combined, and then the exponents are in descending order. Okay, so we have this chart at the bottom of the page here. I'm going to do a few examples, and then we'll leave the rest for you to try on your own. Okay, so first expression here is 3x minus 7. All right, one thing it's nice to do is to kind of think about what the exponents are on the variables. This is 3x to the 1st minus 7. So it is in decreasing order, so standard form is just 3x minus 7. Right? The leading coefficient is the number on the exponent, the biggest exponent. So x to the 1st, so the leading coefficient is 3. The degree, okay, since the exponent is 1, we say the degree is linear. We got that from up here. And finally, the number of terms, when there's 2 terms, we say it's a binomial. Okay. The second example here, right? Let's see. 2x cubed minus 5x squared plus 7x. Those are in order, so I would say that that is in standard form. So I'm just going to rewrite it 2x cubed minus 5x squared plus 7x. Okay, 3, 2, 1. That's what I'm talking about. Exponent 3, exponent 2, exponent 1. The leading coefficient, look at the first term with the biggest exponent. The number in front is 2. When that exponent is 3, the biggest exponent is 3, we call that cubic. And then when there's 3 terms, 1, 2, 3 terms, we call that trinomial. Trinomial. Okay. Let's see here. For the third one, I'm going to say in standard form, my biggest exponent is 2, and then 1, and then the constant term. So we'd say negative x squared. The negative is in front. That comes with the x squared. Plus 6x plus 2. That's standard form. Leading coefficient would be negative 1, because that's in front of the x squared. And then degree name, when it's the biggest exponent is 2, the degree is quadratic. And then finally, 3 terms again is a trinomial. Okay. I'll leave the next 3 for you, but the last one I want to point out, 6x to the 4th minus 8 to the x. Okay, well that exponent there is not an integer, it is not a positive number, so this one is not a polynomial. Okay, flip to the next page for me, please. I want to do a couple here in example 3, adding and subtracting polynomials. Okay, when adding and subtracting polynomials, we combine the like terms. Okay, so these problems really actually aren't new to you, but there's just a little bit we have to focus on. So in the first one, it's 3x squared plus x minus 6 plus x squared plus 4x plus 10. I'm going to find all my like terms, right? And I like to underline. Okay, so 3x squared goes with x squared and makes 4x squared. 3x squared plus x squared makes 4x squared. And then my linear terms that go together, x plus 4x makes plus 5x. And then my constant terms, negative 6 and positive 10, negative 6 plus 10 makes positive 4. So there's my answer, 4x squared plus 5x plus 4. Just combining like terms. Right? Now when it's subtraction, you'll notice I have to have parentheses around it, okay? Because what's really happening is I'm taking this first one, and I'm subtracting the entire second one. Okay, so we get x squared minus 8x, all right, minus x plus 9. So the first thing I'm going to do is actually distribute the negative. So I get x squared minus 8x minus x minus 9. And now I can combine like terms. The only like term I see is the x's. Negative 8x minus x makes negative 9x. So my answer is x squared minus 9x minus 9. Okay. Why don't you pause the video and try C and D and then check your answers. All right, see how you did there with C and D? All right, and then finally, real quick, example 4 here. Notice with C and D, I put my answers in standard form. So originally it wasn't in standard form, and then I brought the biggest exponent term in front. All right, and then example 4, I'm told f of x is this function here, 3x squared plus 2x minus 4, and then g of x is negative 4x squared minus 6x plus 1. So in A, I'm told to do f of x plus g of x. So I'm just going to do this guy plus this guy. All right, and that's going to look like 3x squared plus 2x minus 4 plus negative 4x squared minus 6x plus 1. And I combine my like terms. 3x squared minus 4x squared, or plus negative 4x squared, is negative x squared. And then 2x plus negative 6x is negative 4x. Negative 4 plus 1 is negative 3. If I want to subtract them, I just have to make sure I write parentheses. 3x squared plus 2x minus 4. I don't need them around the first part. I need them around g of x. I need them around whatever I'm subtracting. Negative 4x squared minus 6x plus 1. And then I distribute that negative. So it's 3x squared plus 2x minus 4 plus, because minus negative, plus 4x squared plus 6x minus 1. And when you combine those like terms, you'd get 7x squared plus 8x minus 5. All right, thank you for watching.